The year is 2025, and we are in for an earthquake surge like no other. This may be the year of surprises, but this could be the year that hidden magma chambers shift the Earth's crust with unprecedented consequences. I'm a geophysicist, and this is what we're watching. And yes, we're starting 2025 with a bang, because just a few hours ago a new study was published which shows that the Earth has been wobbling around its axis by up to 8 meters since the early 1990s due to melting ice sheets in Antarctica. Now, does this mean that the ground where you live will be shaking in 2025? Probably not. But it might be a sign of things to come, because there are some regions on Earth where the crust has been moving around much more lately than usual. And in those places, the risk for earthquakes is currently elevated. So let's have a look at whether we're in for an earthquake surge in 2025. First, let me tell you about the paper on the wobble of the Earth. It was published in the journal Nature and reports that since the early 1990s, the Earth's rotation axis has shifted by up to 8 meters relative to the solid ground beneath it. This is quite noticeable against the background of the Earth's overall wobbling, which has an amplitude of roughly 3 meters. The reason for the additional shift is that the ice sheets in Antarctica are melting and the water finds its way into the ocean. Since the water is less dense than rock, this lowers the average density of the Earth and thus makes it slightly more wobbly. Not just that, it also shifts the rotation axis. That's not something we need to worry about. It's just interesting to know how sensitive the Earth is to such changes. What's much more worrisome are these. These are maps of regions on Earth with elevated seismicity, the rate at which earthquakes occur. They come from a paper published last year in the journal Frontiers in Earth Science. The authors of that paper collected data on earthquake rates for the years between 2016 and 2020. They found that in some regions of the world, the rate of earthquakes increased by up to 50%, above the long-term average. What you see in blue are areas where the seismicity went down, and in red those where it went up. And notably, it's not just that the seismicity increased in those regions, it's that it continues to be high. It hasn't gone back down to the long-term average. So what's going on? Before I tell you where exactly this elevated seismicity occurs, let me briefly explain why it matters. Earthquakes happen when rocks break and slip past each other. They release energy that builds up in the Earth's crust. Where and how readily this happens depends on the type of rock and how much stress it's under. You see, the Earth's crust isn't just sitting still on top of the semi-fluid mantle. No, it's slowly, very slowly moving around. On average, the plates move a few centimeters per year, though some move towards each other with tremendous speed. The area where they meet is called a plate boundary. There are 3 types of plate boundaries. At convergent plate boundaries, the denser oceanic plate sinks into the mantle. At divergent plate boundaries, plates move away from each other, and transform boundaries, they slide past each other. Along all these plate boundaries, the rocks are severely deformed, and the energy that's released by the rocks breaking and slipping is what causes earthquakes. The largest earthquakes happen where the plates meet, but smaller ones can also occur within the plates. For example, if stress builds up in one place, then the rocks eventually break and slip, triggering another rock further away to do the same thing. So while scientists can roughly predict where earthquakes are most likely to happen based on where the plate boundaries are, they can't say exactly where and when it will happen. This is why we only have very limited abilities to forecast earthquakes. All we can do is to identify regions with elevated seismicity and then try to estimate how long this elevated seismicity will continue. So, where has the seismicity been elevated recently? Well, take a look at this map. This shows the cumulative number of earthquakes with a magnitude larger than 5 that have happened in the Earth's crust since the beginning of January 2023. And you can clearly see that there are some areas where earthquakes are more numerous than others. A lot of them cluster along plate boundaries, but many also occur far away from plate boundaries, especially in Japan, New Zealand, Central Europe, and along the central and southern part of the North American continent. In some of these areas, the recent uptick in seismicity has lasted several years already. In other places like Japan or New Zealand, the elevated seismicity has lasted for decades. Now, I'm not saying that it's going to rain earthquakes over the next 2 years in any of these regions. All I'm saying is that in some of these places, it might be a good idea to be prepared. Let me give you 2 examples. First, Japan. Japan lies on the western edge of the Eurasian plate, which is being pushed down into the mantle by the Philippine Sea Plate. In total, there are 4 major plates meeting in this region: the Eurasian Plate, the Pacific Plate, the Philippine Sea Plate, and the Okhotsk Plate. The boundary between the Eurasian and the Pacific Plate runs right beneath Japan. And here, too, the seismicity is elevated compared to the long-term average. The thick black line in the middle marks the so-called seismic gap. It's a region where major earthquakes have not occurred in the last 200 years or so. Scientists have been wondering for a long time whether it's just a matter of time until the stress that has built up in this region will cause a major earthquake. The second example is Central Europe. Here, the African and Eurasian plates meet, but the seismicity is not elevated along the entire boundary. Instead, it's elevated in a very narrow band in Italy, Switzerland, and Austria. Interestingly enough, this region has seen an increase in seismicity since the 1960s. It's called the Central European Seismic Sequence. Nobody knows exactly what's going on there. The best guess we have is that it's related to reactivated faults that were caused by the collision of the African and Eurasian plates. These are just 2 examples of the regions where the seismicity has been elevated. There are many more. And it's important to keep an eye on them because while we don't know exactly where and when the next major earthquakes will occur, we can at least try to narrow down the possibilities. Finally, you might wonder why I talk about all this in the context of 2025. Well, it's because the year 2025 is the deadline of the largest international project we have ever undertaken to image the Earth's crust and mantle with unprecedented resolution. It's called the International Heliophysical Year, IIY 2020+5. During this 5-year campaign, more than 200 research institutions from all over the world are working together to acquire the largest collection of geophysical data that we have ever gathered. This includes measurements of the Earth's gravitational field, magnetic field, and the seismic waves that travel through the Earth's interior. With these data, we'll be able to create detailed models of the structure of the Earth and better understand what's going on beneath our feet. The IIY started in 2020 and will end in 2025. If everything goes well, the data analysis will allow us to say something more precise about the probability of large earthquakes in the coming years. In any case, stay tuned. I'll keep you updated. Thanks for watching.